Hi, I'm Max Jenner, and this is the video project on 4.4. This one goes over graphing functions, and I decided to use x squared plus 4x plus 3 as the function I want to graph. And basically, 4.4 goes over a bunch of steps you can use to help you graph and make the whole process a lot simpler. So, starting now, I'll just break down these steps on how to actually graph the graph and work out the steps. So right up at the top, you have the function, and with something like this, to make it easy on yourself, you can break down the function and factor it out. And so with this, you get x plus 3 times x plus 1. And this will make going into the steps a whole lot easier. And so I have 10 steps here. This is mostly just from the homework as kind of a guide, but this problem's not from the homework. And so the first step is finding the x-intercepts. And so what you want to do is just basically set the function equal to 0. And so you take x plus 3 times x plus 1 equal to 0. And with something like this, all you really need to do is flip the sign for each of these numbers. So it is x equals -3 and x equals -1. And so right then and there, you already have your x-intercepts for the function without even having to graph it. And then the second step, y-intercepts, you get fx equals 0 plus 3 times 0 plus 1, because you set x equal to 0 to find the y. And so with that, you get just 3 times 1, and that leaves 3. So the y-intercept of this function is 3. Next, you move on to the asymptotes. And for this function, there actually are no asymptotes, but with vertical, it would be, so this is already the finished graph, but for vertical, you could say if this was going up straight and it never crossed, like, say x equals 2, x equals 2 would be a vertical asymptote, because this line right here would keep going up, but would never cross x equals 2. But on this function, that's not the case, so there are no asymptotes, at least vertical asymptotes. Next step, horizontal and oblique asymptotes, just some more asymptotes, but this function as a whole just doesn't have any asymptotes. Horizontal, it would just be going completely horizontal. The line of the function would never cross that. And then there are no oblique asymptotes either. And that's basically just the slope of the tangent line if the function had one of those, but this function does not. And then for the fifth step, you find the first derivative of the function. So with this one, you would get 2x plus 4, because x squared will go down to 2x, and then you just take away the x from 4x, so you get 2x plus 4. And then you move on to finding the critical numbers. So set the first derivative function equal to 0. So that 0 equals 2x plus 4. Move the 4 over. -4 equals 2x. Divide it all by 2, and then you get x equals -2 for your one critical number. And then with that, you can find where the function is increasing or decreasing with the first derivative. So with x equals -2, since that's the only critical number, you get negative infinity going to -2 and -2 going to infinity, because there's nothing else. And so for first derivative, it is negative on negative infinity to -2 and positive on -2 to infinity. So it's decreasing, and increasing. And then from there, you move on to the second derivative. So you get your first derivative and just find that derivative. So no more 4, and just take away the x, so you're left with 2. And then move on to points of inflection, and you get that from the second derivative. But with this, you equal the second derivative equal to 0. But since there's no x in this, you get 0 equals 2, which isn't true. So cross that out, and there are no points of inflection. And then you can find concavity from the points of inflection, but since there are none, you're working from just the critical numbers that you have. So it goes back to negative infinity to -2 and -2 to infinity. And it's positive the entire time. So the entire function is just concave up. And then from here, you pretty much have all you need to sketch out the graph. And this is a pretty easy one. So you get your critical point, -2, your 2 x-intercepts, your y-intercept at 3, and this line right here is a function. The straight line going up is the derivative, and this one is showing concavity. It's completely positive, that's why it's concave up, and this one goes from negative to positive right at 2, which shows here. So it's decreasing and then increasing. And that is basically the sum of this entire unit, is just working out functions to break it down in the steps like this, find the answers to each of these problems,